What is going on, everyone? Happy New Year. Homework assignment 47. Today's objective, I can solve systems of equations with different types of solutions. So, we have spoken about this before. We have seen it before, but I just wanted to throw it out there one more time just to show you in the context that we've been seeing these problems, okay? So let's actually just go right to it. So we're going to be able to identify the number of solutions that a system has, okay? And we're going to go ahead and use whatever methods of solving that we can, okay? Remember what everything means. Infinite number of solutions means that, our lines are, if we're talking about a graph, our lines are right on top of each other because they are basically the same lines because they're both the same equations. No solution means that my lines will never touch, they're parallel lines if we're talking about graphs. Meaning that there is no number that will satisfy, no coordinate that will satisfy the equations, that will fit the equations. So let's go ahead and see. Some of them you can notice right away if they're going to be the number of solutions that we're going to have, but others we're going to have to work a little bit harder. So taking a look at this system, I'm going to use the elimination method to solve this system. So the first thing I need to do is I need to get my coefficients of my variables the same. So let's see if I can try to eliminate my x's. I'm going to multiply everything by 2. Okay. So when I multiply everything by 2, I end up with 2x plus 2y equals 6. And my bottom equation is 2x plus 2y equals 6. Okay. We should sort of already be able to see something that's going on here. Okay. So let's go ahead and I'm going to say I'm going to subtract my x's. I'm going to eliminate my x's by subtracting. Okay. So 2x minus 2x is 0. But notice what happens here. I have a positive 2y and a positive 2y. Also cancels out to make 0. So I have 0 on that side. Then I have 6 minus 6 on this side. So I have 0 over here. And we're left with the equation that 0 is equal to 0. And we ask ourselves, does 0 equal 0? Sure does. So because we have a number is equal to itself, even if it's 0, then that means that we are going to have an infinitely many solutions. Okay? And this is going to be the case no matter what this number ends up being. Maybe we could have, I don't know, we could have 5 equals 5. -2 equals -2. No matter what happens, once we get to a point where we see this, 0 equals 0, 5 equals 5, -2 equals -2, we can automatically identify that there is an infinite number of solutions, infinitely many solutions, okay? There's no check that we could really do. We could identify it right away. We could even identify the fact that both of the equations were exactly the same. This one's a little easier than the others that we might see, but if both the equations are exactly the same, we have to have an infinite number of solutions. Let's see our next one. So we have y is equal to -x plus 3, and we have 2x plus 2y is equal to 4. All right. This seems to lend itself to the substitution method. So I'm going to take this -x plus 3, and I'm going to substitute it for y in the equation below, because y is equal to -x plus 3. So let's rewrite. So I have 2x plus 2, I'll write that in black, -x plus 3 is equal to 4. All right, let's distribute. We have 2x minus 2x plus 6 is equal to 4. All right, 2x minus 2x is 0. So these kind of cancel out. And we're left with 6 is equal to 4. And we ask ourselves, is 6 equal to 4? 6 is definitely not equal to 4. Therefore, we will have no solution. If we get a number is equal to some other number, then we're given that our system does not have any solution at all. All right. And that's really it, just the two special types of solutions. Any other time, let's say if we were to kind of extend this and we were to say, if you were to ask me, well, what does one solution look like? Well, one solution looks like kind of the same things that we've seen before. If you get, that x is equal to 3 and y is equal to -5, well, then your solution is 3, -5, and that is your one solution, okay? So just throwing that out there for you. You know what no solution looks like. You know what infinitely many solutions looks like. You know what one solution looks like, all right? Some problems on Regents exams and other tests might ask you, how many solutions are there to the following system? And you would be able to answer one solution, no solution, or infinitely many solution, all right? If we're talking about system of linear equations, that's the only possible outcomes that we can have. Check out those practice problems. If you got any questions, again, I'm always going to say jot those questions down, bring them to class the next day. See you then.